Hello everyone, good morning and welcome to today's class. Komu say how much can I score in GATE by following this series? See, this series will be beneficial to you if you have already you have knowledge about what we are talking, okay? Because these are questions simply, okay? So without having prior knowledge, I don't think कि उतनी effective होगी. But yes, if you have a bit knowledge, थोड़ी सी भी knowledge है, if you have knowledge about the subjects, then I feel that you will be able to have a good score in your GATE exams, because mostly the questions that I have taken over here are from your previous GATE exams, or they are from books that have questions for GATE. Okay, so I feel that you will be able to score good marks. Okay, and plus I have taken basic questions as well, so that you can have a knowledge कि मतलब सिर्फ ऊपर ऊपर नहीं, but deep knowledge also you can have. Okay, so I have tried my level best to add all the questions. Some questions still ऐसा नहीं है कि I have covered each and every question from each and every topic, but I have tried कि जितने भी questions possible हो सकते हैं from each and every topic that we can have. Okay, so good morning Anu, good morning Sai, good morning Kirti, good morning Deepak, good morning Tikenjit. Okay, so yesterday we have discussed few questions. We have covered all these questions, right? And we have done this question. This was the last question. Hello Tanshri. Now this is the next question. In which of the memory allocation techniques internal fragmentation can arise? Yes. What do you think is the answer of this question? In which of the memory allocation techniques internal fragmentation can arise? Only one person is giving the answer. What about others? I hope you are aware about these concepts: segmentation, paging, segmentation with paging, right? Okay. So internal fragmentation can arise in paging. Okay, पेजिंग इज द आंसर. इंटरनल फ्रेगमेंटेशन जो है वो आपकी पेजिंग में होती है. पेजिंग डज नॉट कॉज एक्सटर्नल फ्रेगमेंटेशन, बट पेजिंग कॉजेज इंटरनल fragmentation. Okay, good morning Mumgeshwari. I hope this point is clear to everyone. Okay, so remember this, that internal fragmentation जो है it is caused in paging, not in segmentation. Okay, moving on. Dash is a high-speed cache used to hold recently referenced page table entries, a part of paged virtual memory. So Dash is a high-speed cache used to hold recently referenced page table entries, a part of paged virtual memory. So what is a cache? Now basically you have to just remember कि they are talking about cache. ठीक है? So out of these, which of the following is a cache? सी न्यूमेरिकल्स जो होते हैं वो एवरीबॉडी इज एबल टू डू, बिकॉज न्यूमेरिकल्स जो हैं एवरीवन प्रैक्टिस, राइट? न्यूमेरिकल्स मेजर हमारी फोकस न्यूमेरिकल्स पे होता है, बट वाइल कवरिंग दोज न्यूमेरिकल्स नो वी जस्ट फॉरगेट टू कवर द मेजर थिंग दैट इज योर योर थ्योरी क्वेश्चंस, बिकॉज इफ यू नो दिस थ्योरी सो यू आर एबल टू मतलब थ्योरी के क्वेश्चंस बेसिकली आते हैं बहुत डीप, मतलब इतना नहीं होता कि ठीक है जैसे अब ये क्वेश्चन था आपका, दिस इज योर इंटरनल फ्रेगमेंटेशन, इट इज अ वेरी बेसिक क्वेश्चन. ठीक है. So you should know these things and then you should move forward with your topic. Okay, so always try कि whenever you are doing a topic, whenever you have completed one topic, just try, instead of going with the numerical first, go and try the theory questions from that topic. Because if you are well with the theory questions, this means that you have prepared your topic very very well. ठीक है. So correct, the correct answer is TLB, that is translation look aside buffer. Good. Now, in a virtual memory environment, segmentation and page tables are stored in the cache and do not add any substantial overhead. Slow down the computer system considerable. Segmentation and page tables are stored in the RAM. None of the above. What do you think is the answer for this one? What is the answer for 17th question, virtual memory environment? So segmentation and correct. C, segmentation and page tables are stored in RAM. Okay, so we store all the segmentation tables, all the page tables in the RAM. Okay, so RAM is the answer. Correct. Now, size of virtual memory depends on. So these are basic questions, है ना? They are not so high questions, but see, now with these questions you will come to know जिसका सही आ रहा है very good, जिसका गलत आ रहा है they'll come to know कि okay, we have to focus more on this part right now. ठीक है? So size of virtual memory depends on, and memory management is one of the most important topics from your computer science, I'm telling you. ठीक है? Not from operating system but from computer science. So please do study this topic very nicely. Okay, size of virtual memory depends on. What is the answer for 18th question, everyone? It will be very good that if you please write 18 also with your answers, so I may know that which question you are talking about. Now people have answered C, I don't know what question they are answering, so please do this thing, that please write 18 as well, question number as well. Okay, so size of virtual memory depends on size of main memory. Everyone, do you think this? Seriously, everyone, size of virtual memory depends on size of main memory? Anybody is having any other answer? The correct answer is size of address bus. So size of virtual memory will depend on the size of your address bus. Okay, remember this, it does not depend on main memory, it depends on address bus. Okay, size of virtual memory depends on size of address bus. Next question. Now this is one question. The address sequence generated by tracing a particular program executing in a pure demand based paging system, okay, with 100 records per page with one free main memory frame is recorded as follows. What is the number of page faults? So they have given you certain pages. Okay, these are your pages, and they are telling you that the system is basically a demand based paging system. Okay, and you can have 100 records per page, means one page can have 100 records. And then these are the sequences, these are the page sequences that you have. So you have to tell that how many of the following will have a page fault. So try it. You must have done these questions earlier also, somewhere, but just try by doing it. Okay, answer rata bhi hai tab bhi just try once. Okay, सो डिमांड बेस्ड पेजिंग सिस्टम क्या होता है कि वी आर आस्किंग, वी आर डिमांडिंग फॉर अ पेज, है ना, एंड देन दैट पेज विल बी ब्रॉट इन टू योर फॉर योर व्हाट यू से फॉर इन फॉर पेजिंग, मतलब पेजिंग पर्पज पे व्हेनेवर यू रिक्वायर फॉर अ पेज देन दैट पेज विल बी ब्रॉट. है ना. That is your demand based paging system. The condition is now that 100 records per page means that if you want one page you have to bring 100 records. मतलब अगर आपको 100 चाहिए so you have to bring at least 100 records आपके आने चाहिए because the range is 100 records per page. So try doing like that. Okay, so what is the answer for this one? Okay, now see over here. Now see, first page is what? First page is 100. Okay, so when I require 100 page number, so I have to bring how many records? I have to bring the ranges of 100 records per page, है ना. So means the range will be from 100. If I want तो range क्या हो जाएगी 100 से, the range will be from 100 to 199. Yes or no? है ना. मतलब if you have this, I think you remember this, 199 minus 100 plus 1. So this will be 99 plus 1, that is 100. So when you want page number 100, then you will require 100 to 199 pages so that you can access the 100 page number. So now you have in your memory, you have these many pages. Okay, the range, मतलब if I say that this is your memory, let me just write it like this. Okay, sorry, this is the memory. Okay, now what I want, now there are pages somewhere in my memory. Now what they are saying that you want 100 page number. So अब आप मुझे बताओ अगर आपको 100 चाहिए and range is what? Range is that they are saying 100 records per page. मतलब if you wanting one page में कितने records है? 100. So you want 101. So range क्या हो जाएगी आपके पास? You have to bring 100 to 199 pages and then you can access this 101. Okay, done. Now, so earlier there was nothing in this and now I brought this page. So this is one page fault. Next is 200. Now tell me, with me I have 100 to 199 records, है ना? And I need what? I need 200, but 200 is not in this range. So what I will do, I will move this back. I don't require this anymore. Now I'll bring the page from 200 to 299. Now the records that I need are from 200 to 299 because I need 200 page. So this again is a page fault. Now next is 430. Now 430 does not lie in this range. So again what I will do, I'll move this, I'll remove this and I'll bring pages from 400 to or 432. Yes everyone, 400 to 499. Yes or no? ऐसी करोगे? So now this again is your page fault. Now if you see 499, now next is, this one is page fault, this one is page fault, this one is page fault. Now next is 499. Now if you see here, 499 is already with you. You do not need to bring it from somewhere. 499 आपके पास already present है. So that is why this won't be a page fault because 499 is already present with you. 510 will cause a page fault. ठीक है, 530 will not cause a page fault, 560 will not cause a page fault, 120 will cause a page fault, 220 will cause a page fault, 240, 260 will not cause any page fault, and 320 will cause the another page fault. So how many page faults do we have? We have 7 page faults. Clear हुआ ये वाला question? How we are doing this question? Basically what they are saying is they are saying that you can bring 100 records at one time. Okay, so when initially you have nothing with you, ठीक है, but when you have raised a demand of record 100, so with 100 you will bring 100 records, है ना. मतलब अगर आप एक record ला रहे हो, so this is a condition that one page can bring 100 records. So you need 100 records with you. So when you are asking for 100, and this is how we can have that 199 minus 100 plus 1 will give you 100 records. So 100 से 199 की range you will get. So this is one page fault, है ना. Then next was 200. Now if you see, 200 was not in this range. So for this, I have to move this out and bring another record so that I can access 200. So that is how you will do these questions, and the answer will come out to be 7. Clear everyone? I hope this is clear to everyone, है ना? कोई doubt नहीं है? Now, moving on for the next question. In virtual memory systems, dynamic address translation is what? Dynamic address translation is the hardware necessary to implement paging, stores pages at specific locations on disk, is useless when swapping is used, is part of operating system paging algorithm. So what is the answer for 20th one? So what is dynamic address translation? So the correct answer for this question is option number A. Okay, so dynamic address translation is the hardware that is necessary for implementing paging. Okay, moving on with the next question. चलो, okay, Desh Bandhu, I'll explain this 19th question at the end. Okay, just wait, I'll explain it at the end. Now, when there is enough memory to fit a process in memory, but the space is not contiguous, what do we need? We need, what is that? So there is enough memory to fit a process in memory, but we do not have the space continuously. So the space is not contiguous. We need what? What do we need? Internal fragmentation, virtual fragmentation, external fragmentation, or none of them? What is this case? That memory to बहुत है, but the space is not continuous. What is it? So it is your external fragmentation. ठीक है, सो दिस एक्सटर्नल फ्रेगमेंटेशन, इंटरनल फ्रेगमेंटेशन बहुत इंपॉर्टेंट है. ठीक है, सो ट्राई कि आप ये चीज़ें जो टर्म्स हैं, यू आर नॉट कंफ्यूज विद दीज टर्म्स. सो करेक्ट आंसर इज external fragmentation. Done? Next. Now, a computer system supports 32-bit virtual addresses as well as 32-bit physical addresses. Since the virtual address space is of the same size as the physical address space, operating system designers decide to get rid of virtual memory entirely. So which of the following is true? Efficient implementation of multi-user support is no longer possible. Processor cache organization can be made more efficient now. Hardware support for memory management is no longer needed. CPU scheduling can be made more efficient now. So what do you think is the answer? What is the answer for 22? Correct. Hardware support for memory management is no longer needed. So if you see that whenever we have this memory management, virtual memory, we have this concept of memory management unit, right? MMU. So this is a basic hardware only, है ना? इसमें कुछ components होते that we use for having this, for introducing this concept of virtual memory. Okay, so when we do not require virtual memory, so hardware support जो है आपका, that will no longer be needed. Okay. Now, a CPU generates 32-bit virtual address. Page size is 4 KB. Processor has a translation look aside buffer which can hold a total of 128 page table entries and is 4-way set associative. So minimum size of TLB tag is. So basically they are saying that you have virtual address bits, you have page size, you have number of page table entries, and you have what type of set associative it is. Okay, you have to find the size of tag. This is also easy, थोड़ा सा बस घुमा हुआ है, but it is very very easy. Correct, correct, Deepak. So what about this question? So they have given us that CPU is generating 32-bit virtual address. So we know that the size of any instruction is what? It is your 32 bits. Address is 32-bit. Okay. Now, then we have, now if you see here, we have this 4-way set associative. So if you remember in cache mapping, I told you that this is your tag bit, these are your number of set, okay, and this is your page offset or block offset. So page size is 4 KB. So 4 KB can be written as 2 raised to power 12 bytes. Yes or no? So page offset will become what? 12 bytes. Page offset or block offset, okay? 12 bits, sorry. The processor has a translation look aside buffer. Okay, so you know that translation look aside buffer is what? It is a type of cache, है ना? That can hold a total of 128 page table entries and is 4-way set associative. So if you have to find number of set, okay, I have told you, in, if you remember, if you have seen this class, number of sets is equal to 128, that is your cache size, divide by 4, that is your p-way set associative, है ना? So this will turn out to be 2 raised to power 7 divided by 2 raised to power 2, that is 2 raised to power 5. So this term will come out to be 5. Now 32, and this is what? 17. So 32 minus 17 will give you 15. So this is your tag. So tag bits कितनी हो गई? 15 bits are for your tag bits. Okay everyone. देशबंधु, I think this is clear to you now कि 15 कैसे आया है, 11 नहीं आएगा इसमें. Okay, so now when we discussed this topic, so there we were having a separate term like cache size itni hai, cache block itna hai, and like this they have given us. But here what they have done, instead of cache they have given you a translation look aside buffer, and just now we have studied that translation look aside buffer itself is a cache, है ना? So now they're saying it can hold total of 128 page table entries. मतलब size is basically 128 का size है. It can hold 128 entries and is 4-way set associative. So I hope you know this formula. Number of set is equal to cache size divided by p, that is this 4-way. I think this is clear to everyone now. Now moving on. Consider a computer system with byte addressable primary memory of size 2 raised to power 32 bytes. Assume that computer system has a direct mapped cache of size 32 KB, where 1 KB is equal to 2 raised to power 10 bytes, and each cache block is of 64 bytes. So again the same question, but they have clearly mentioned that you are using a direct mapped cache. So they are asking size of tag field. So what will be this? What will be this answer? What will be the answer for this question? So direct mapped में we have tag, then we have cache, and then number of lines, and then we have block offset or cache offset. So what will be the total bits that will be there? 32, right? Then what they are saying that cache size है आपका 32 KB and cache block है 64 bytes का. So 64 bytes is equal to 2 raised to power 6 bytes, that is ये आपका 6 bits हो गया. Yes. Then 32 KB. So 32 KB is what? 2 raised to power 15. Yes or no? So this will turn out to be no. So 2 raised to power 15 हो गया इसका आंसर, है ना? मतलब 2 raised to power 15 cache. So number of lines was equal to number of lines Number of lines in cache is cache size divided by block offset, that is 2 raised to power 15 divided by 2 raised to power 6, right? So this will turn out to be 15 minus 6, that is 2 raised to power 9. So that means here you will get 9. Now what will be the tag one? So 32 minus 9 plus 6 is 15, that is 17. So tag bits are 17. So you will get 17 over here. So this question was asked in GATE 2021. So it is such an easy question, है ना? कुछ भी नहीं है इस question में. It is just कि you have to just मतलब कुछ बस formula आपको पता होना चाहिए. Nothing else. Okay, so if anybody who has not seen this video of direct mapping and all these things, cache mapping, so just I'll give you a link, ठीक है? आपको if you want to watch, so please message me on Telegram group, आपको पता ही है, ठीक है? So that I can inform you, I can give you the link of that class. Okay, now moving on. In the context of operating system, which of the following statements are correct with respect to paging? So now they have given you 4 statements and more than one statement is correct. Okay, so they are asking that with respect to paging, which of the following statements are correct? So what is the answer for this one? Now out of A and B, one is saying paging helps solve the issue of external fragmentation, and it is saying page size has no impact on internal fragmentation. So what do you think is the answer for this question? Paging incurs memory overhead and multi-level paging is necessary to support pages of different sizes. So paging helps solve the issue of external fragmentation. This is true. I hope you all know this. Right? Then next, page size has no impact. This is false. Now, paging incurs memory overhead. Is it true or false? This statement is true. Why? Because when you do paging, okay, so when you implement paging, you require the managing of page tables, है ना? Because we have the concept of page tables in paging. So for that page table, we require certain additional memory. Okay. So we have this concept of paging, okay? In paging we have certain page tables. So when we have to, so that page tables also have to be stored somewhere. So for page tables we require additional memory. So that is why they are saying paging incurs memory overhead, and that statement is true. Then we have multi-level paging is necessary to support pages of different sizes. This is false. Okay, so what is the correct one is that कि multi-level paging कब require होती है? Multi-level paging is required when size of page table is greater than frame size. Okay, so we have page size, page table, frame size. Okay, so now in this case we have multi-level paging. So that is why the correct answers are option A and option C. Okay, so paging helps solve the issue of external fragmentation and paging incurs memory overhead. Now, in a paged memory, page hit ratio is 0.40. Time required to access a page in secondary memory is equal to 120 nanoseconds. Time required to access a page in primary memory is 15 nanoseconds. So average time required to access a page is, very easy question, सिंपल सा फॉर्मूला है इसका, है ना. So when we have to find average access time, now there are so many different formulas for this, so you have to remember that when they have given you secondary memory access time and they have given you primary memory access time, so the formula is that hit ratio means you have found the page in your primary memory, so hit ratio multiplied by primary memory access time, okay, I'll write 80 over here, plus then now when you, why you're accessing secondary memory, because you didn't find the page in primary memory, so this will be 1 minus hit ratio, right, multiplied by secondary memory accessing time. Simple the formula, okay. So then what we have is hit ratio is 0.4, so 0.4 multiplied by 15 plus 1 minus 0.4 multiplied by 120. So when you will solve this, you will get, this will turn out to be 6 and this will turn out to be 72. So the answer will come out to be 78. So the correct answer is option number D, that is 78. Good. Good. So almost everyone is giving the right answer. So I think preparation आप लोग की बहुत अच्छी चल रही है for exam, whatever exam you are preparing for, either it is GATE or it is your NET. So it's good. ठीक है, but just keep practicing. ठीक है, जब तक exam नहीं हो तब तक keep on practicing the questions so that you do not miss any concepts. Okay. Now I have one question. This is related to round robin. So let me just add it. Okay. So we have process number. I think maybe we might have done this question as well somewhere before in any of the previous classes. So we have one. Oh, just wait. Two, 3, 4, 5, 6 and 5, 4, 3, 1, 2, 6, 5, 4, 3, 1, 2, 6 and burst time is 5, 6, 7, 9, 2 and 3. So you have to solve this with round robin, okay, and time quantum given is 3. So try it and tell me what will be the average waiting time. Average waiting time you have to tell for this question, okay. So this is round robin, so definitely we'll have the concept of ready queue with us, right? So the first process that will enter over here is with the arrival time 1, है ना. Now we don't have any other process with us, we just have arrival time 1. So now at time 0, from 0 to 1, we will have this CPU as idle. So nothing will be there in the CPU. Then at 1, we have what? We have 4. Okay, process number 4. Process number 4 arrived. So in ready queue, if this is our ready queue with us. So first process that came was P4, है ना? Then P4 came, so what is the time quantum? 3, so it will run till 3, so that is now your time is 4. Now when my time was 2, the process P5 came. When time was 3, process P3 came. When time was 4, process P2 came, and then it executed for 3, that is your 6, and process P4 came again back into the ready queue, right or not? Now next I'll execute P5, because in my ready queue I have P5. P5 again will execute for 3 time quantum, but burst time is 2 only, so 6, and this will turn out to be 0. Now when was 5, timeline was 5, P1 arrived, and then at 6, P6 arrived, and P5 is completed, so I won't write it back again. Next I have P3. Now all the processes have entered my ready queue, है ना? Now I have what? P3. So what is P3? P3 this. So P3 will execute for 3, that is 9, and this will turn out to be 4. So P3 will come over here. Then I have P2. So P2 will again execute for 3 time unit. So 12, and this will turn out to be 3. So P2 will come again over here. Then next I have P4. So like this you can carry it forward. So P4 will again 15, and this will turn out to be 3, and P4 will come over here. Then I have P1. P1 will execute for 3, 15 is 18, and this will become 2. So P1 will come over here. Then P6. So P6 is 3 only, so P6 will execute completely, that is 21, and this will be 0. Now I have P3 again. So P3 again will execute for 3 time unit, that is 24, and this will become over here 1. So I'll write over here P3. So I hope this is clear to you. We can do this now, है ना? I'll complete it. So next is P2. P2 is having time as 3, so this is 27. So this will be 0. And I have P4. P4 will execute for 30, and it will be 0. P1 hai. P1 will execute for 2, that is 32, 0, and P3 will execute for 1, that is 33. Correct? Then what we have to find? Now we have to find completion time. So completion time we can find from this only. So what is the completion of P1? 32, P2 27, P3 33, P4 30, P5 6, and P6 21. Then what is turnaround time? Turnaround time is completion time minus arrival time. So this will give you, I'll just write here, 27, 23, 30, 29, 4, and 15. And what will be the waiting time? 22, 17. What is waiting time? Waiting time is equal to turnaround time minus burst time. Okay, so 23, 20, 2, and 12. So when you will add, you will get 96. So average waiting time will be 96 divided by 6, that is 16. So 16 will be your answer. Everyone getting 16 or not? ओके, सॉल्व इट एंड टेल मी क्या आ रहा है आंसर. Meanwhile, I'll write another question. ओके, एंड व्हाट अबाउट अदर्स? बाकी का हुआ सॉल्व? बाकी प्रीवियस क्वेश्चन सॉल्व किया आप लोगों ने? दिस इज द क्वेश्चन नाउ, बट फर्स्ट टेल मी दिस क्वेश्चन एवरीबॉडी. हुआ सबका? एवरीवन? Nobody has given any answer related to this question. What about this one? ये क्वेश्चन हो गया सबका एवरीवन? Nobody has given the answer for this question. Before moving forward, tell me this one done or not. Sharanya and Priyanka, what about this one? ये हो गया आप लोगों का ये वाला राउंड रॉबिन वाला? सबका मेस्ड हो गया? ऐसे कैसे किया आप लोगों ने कि मेस हो गया? हाँ, ओके चलो ये वाला करो. सो दे आर सेइंग दैट दीज आर द प्रोसेस रिक्वेस्ट 300K, 25K, 125K and 50K, and this is the memory given to you, out of which 50K blocks, 50K, 300K and 600K are already occupied. ठीक है, so they are asking that using which method you can allocate all the processes in these given blocks. Okay, the ones where memory is not occupied. ओके अनु, ठीक है, करेक्ट. टर्न अराउंड टाइम जो टोटल आएगा, आई डोंट हैव कैलकुलेटेड एवरेज टर्न अराउंड टाइम, बट टोटल विल बी 128. सो व्हेन विल डिवाइड 128 by 6, सो एवरेज वेटिंग टाइम इज 93 और एवरेज वेटिंग टाइम. चेक करो वेयर इज द डिफरेंस, क्या गड़बड़ हो रही है, क्या गलत आ रहा है. तो this is what you will get. ठीक है, इस वाले क्वेश्चन में राउंड रॉबिन में. So try it once. I'll also see to it. I think the question answer is this only, 16. Okay. Okay, so now in this question what you will do, first we'll try with first fit. Okay, so with first fit we will try. So I'm using this blue pen for the first fit. So now I have 300k. So 300k, first fit says what? First fit says that when you have to enter a program, the first block where you can fit this process, just give that block to this particular process. Now I have 300k, I cannot accommodate 300k in this 150k, so I'll see the next block. Next block is 350. So what I'll do, I will take 300 from this and I will allocate it to this 300k process. Next I have 25k. So 25k, always I'll move from this side. So 25k can be easily accommodated in your 150. है ना? So now what you will do, you can accommodate 25k over here. Next I have 125. Now 150 minus 25 is 125 only, so I can accommodate 125 over here. Then next is 50 and the remaining is 50 from this block. So first fit की help से you have allocated all the processes. Now let's try with the help of best fit, whether best fit will do the same or not. So this is your 50k already occupied, then this is your 150k, then this is also already occupied, this is 350, and this is 600 already occupied. Okay, so this is we are trying with best fit. Now best fit mein what we will do, we'll go with 300k. So 300k best fit will come under this block, है ना? So we will give 300k to this one. So done, given. Right, so this is your 300k and the remaining is your 50k now. Okay, so 300k ho gaya. Next is 25k. So now this we are having, this is we are having what? This is we are having 150k and this much is 50. So 25 best will fit under what? Best 25 will fit under this remaining block, that is 25k will come over here and this remaining size will be again of 25k. Next I have 125. So 125 I can easily accommodate over here. So 125 यहाँ आ गया and this remaining block is of 25k. Now I have 50k with me, but here if you see 25 over here I have and 25 over here. So this is what? This is what type of fragmentation? This is which type of fragmentation? 25 over here and 25 over here, but I need 50 and I cannot use this because it is not continuous. This is an example of external fragmentation, right? So external fragmentation says that you have space with you, but that space is not continuous. So best fit की help से I cannot allocate all the processes. So answer will be option number B. Both? No, both नहीं. Both नहीं answer. ठीक है, आंसर विल बी ऑप्शन नंबर बी, दैट इज फर्स्ट फिट बट नॉट बेस्ट फिट. क्लियर? यस, ओनली फर्स्ट फिट. तो वन मोर क्वेश्चन वील डू. ठीक है, अभी ऑपरेटिंग सिस्टम वील कैरी फॉर अराउंड 1 or 2-3 days. ठीक है, जिससे कि वी कैन प्रैक्टिस मोर एंड मोर क्वेश्चंस एंड देन वी विल स्विच टू DBMS. So now in this question, this is a basic questions, that is LAS or virtual address space. I hope you know this. That is your 128 KB. Physical address space is also 128 KB. So and page size is 4 KB. Okay, so you have to tell logical address bits, then you have to tell physical address bits, then you have to tell the page offset. Okay, then you have to tell number of pages, then you have to tell number of frames. So with this one question you will be, I'll come to know that whether you know all the questions or not. Okay, then you have to tell page table entry, and then you have to tell page table size. Okay, so first tell me what is LA, what will be LA? First let us start one by one. What will be LA? So now as you can see here, this is 128 KB. So 128 KB ko I can write it as 2 raised to power 17 bytes. Again 128 KB है, so I can write it as 2 raised to power 17 bytes, and page size 4 KB है, so it can be written as 2 raised to power 12 bytes. Yes or no? So what will be LA? LA is basically logical address space में कितनी bits you are using, that is LA, logical address. So that will be 17 bits. Then 17. What about PA? PA is basically the number of bits in physical address space. So that is again 17 bits. What is page offset? Page offset. Page offset is bits in your page. So that is 12. 12 bits. So these are all in your bits. Now what will be number of pages? Number of pages. So when you have to find number of pages, what is the formula? Number of pages ka? Number of pages is LAS divided by page size. Okay, so what is LAS? LAS is 2 raised to power 17 divided by 2 raised to power 12, that is 2 raised to power 5. नहीं बट स्टिल आई हैव गिवन अ क्वेश्चन सो दैट आप ट्राई कर सको. जब सेम होता है सो देयर इज नो नीड फॉर वर्चुअल मेमोरी. ठीक है, जस्ट फॉर प्रैक्टिस आई हैव गिवन यू, जिससे कि फॉर्मूले, जस्ट टू चेक कि फॉर्मूले आते हैं कि नहीं सबको. दैट्स इट. So what will be number of pages? I can write it as 2 raised to power 5, that is 32. Number of frames. Number of frames का formula क्या है? Number of frames is PAS upon frame size, and I hope you know that frame size is always equal to page size, right? So this will also be 2 raised to power 5, that is 32. Now page table entry. So what will be page table entry? So for page table entry, remember number of entries in a page table is equal to number of pages in a process. ठीक है, so how many pages you have, that same number of entries you will have in a page table. ठीक है, so how many pages I have? I have 2 raised to power 5 pages. So how many entries I'll be there? There'll be, what will be the answer? So number of entries कितनी हो गई? अगर 32 पेजेस हैं आपके पास, ठीक है, so नंबर ऑफ एंट्रीज कितनी हो जाएंगी? You can find it as 2L minus P, right? So that will be 32. Yes. Okay, then पेज टेबल साइज कैसे निकालते हैं? व्हाट इज द फॉर्मूला फॉर पेज टेबल साइज? सो फॉर्मूला फॉर पेज टेबल साइज इज नंबर ऑफ एंट्रीज multiplied by each entry size. Okay. Mm, 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 mm. तो पेज टेबल साइज कितना हो गया आपका फिर? Wait, I'll just check this concept of page table entry because um, wait, just leave these two things, ठीक है? इन दोनों को छोड़ दो. I'll tell you this tomorrow. Okay, just leave all this because I think something is wrong over here. ठीक है? So we'll discuss this tomorrow in tomorrow's class. ठीक है? So just leave these two things over here. Okay? So now देश बंधु आप क्लास में हो? Page table entry. Page table entry. Page table entry is 32 bits. 32 bits ना, right? 32 bits means अगर आप 32 bits ले रहे हो, नहीं 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 नहीं, नो नो नो. पेज टेबल एंट्री क्या होता है? पेज टेबल एंट्री बेसिकली होता है कि हाउ मेनी एंट्रीज यू आर, मतलब आपकी पेज टेबल में कितनी एंट्रीज हो रही है. राइट और नो? एज फ्रेम नंबर इज 5, अप्रॉक्स पेज टेबल एंट्री साइज इज 2 bytes. नो. हाँ, सो आई कम बैक टू दिस क्वेश्चन टुमारो. ठीक है, डोंट वरी बिकॉज देर आर सम थिंग्स जो यहाँ पे कुछ गड़बड़ हो रही है. सो आई जस्ट सी टू इट एंड देन टुमारो आई टेल यू दिस थिंग. ठीक है? हाँ जी. सो लेट मी जस्ट डिस्कस दिस क्वेश्चन वंस. वेयर इज दैट क्वेश्चन? या दिस वन. हाँ जी. सो इसमें क्या प्रॉब्लम हो रही थी, क्या समझ नहीं आया? यस धनश्री, क्लास है इवनिंग में एंड वील डिस्कस द फ्लैग्स कॉन्सेप्ट. ठीक है? पेज टेबल एंट्री का फॉर्मूला आई कैन, मतलब आई हैव दिस फॉर्मूला दैट इज पेज table size is equal to number of pages multiply by page table entry. So now let us try doing this thing. So page table size कितना था हमारे पास? Page table size, अच्छा पेज टेबल साइज ही हमें कैलकुलेट करना है, राइट है ना? this is the formula basically, है ना? So now with this formula we can if we have either of the one, so I'll just page table entry. चलो मैं देख के बताऊंगी आपको वाली चीज. ठीक है? हाँ जी. हाँ हाँ. Now see 19 में, just see here what they are saying that you are using demand based paging system, है ना? So demand based paging system क्या होता है? Basically it says that whenever you call a page whenever it is in need of, ठीक है? Whenever there is a demand of that particular page, तब हम उस पेज को कॉल कर रहे हैं. That is your demand based paging system. Now they are saying that in demand based paging system you are having 100 records per page. मतलब in one page how many records you have? One page contains 100 records. So if you are calling one page, you will bring 100 records with you. ठीक है. So now next what they are saying, they're asking ki how many page faults do you have. So if you see here, I'll just remove all this, ठीक है. So now the page number that you have is 100, ठीक है. In your this block right now you don't have any page or any record with you. So in order to access this 100, what you have to do, you have to bring this 100 from memory to your block, है ना. So what you will do, and now if you want to bring one page with you that will contain 100, you have to bring 100 records. So I have told you, I think you know this formula, that if range is given to us from L to M and we have to find that how many elements are there in total from this given range, so the formula is L minus M plus 1. Okay, so if I have 100, if my starting page is 100, so from 100 to 199 की range तक I have to bring the records. Why? Because 199 minus 100 plus 1 will give you 100. So and how many records are there? 100 records. So 100, for 100 you will bring how many pages? You will bring 100 to 199 records, and since it was not present with you, so that is why it will be treated as one page fault. Okay, so now this is your page fault. Next was 200. Now what you have with you, you have with you 100 to 199 records, and now you need is 200, and 200 does not lie in this range. So that is why you will, because now you have one free main memory frame only, so you will send this back and you will bring that block that will have 200 in it. So 200 की रेंज क्या होगी? 200 से 299. So again this is your second page fault, ठीक है. Then we have what? Then we have 430. Now we saw 430 and now we can see that 200 से 299 does not contain 430. So I will move this back and I will bring the range from 400 to 499. Right, and now 430 will be in this range, so this is my third page fault. Next I have 499. Now if you see, 499 is already present in this block, so I do not require to bring it from main memory. So that is why this is no page fault. So like this you will do your further calculation. Now 510 hai, 510 is not in this block, so I will bring it from somewhere. So 500 की range क्या हो गई? 500 to 599. So all the ones that are in this range, there will be no page fault. So 530 इस range में आएगा, no page fault. 560 इस range में आएगा, no page fault. अब 120 चाहिए, so 120 again we have to move this range out and we have to bring range 100 to 199. So this will be a page fault. This will again be a page fault because वो इस range में नहीं आ रहा. This won't be a page fault, this won't be a page fault, but again this will be a page fault and this won't be a page fault. So total page faults हो गए 1 2 3 4 5 6 7. अब clear हुआ? Page table entry contains frame number and additional bits like this. Here we have 2 raised to power 5 frames, so frame number is 5 bits. So approx page table entry is 2 bytes. Page table size हो गया 2 raised to power 5 into 2 bytes. Okay, ठीक है. So whatever you are saying, ठीक है, बात आप लोगों की सही है, but I'll see this question and then I'll give you the answers, ठीक है. So that's it for today. शाम को at 6 PM we have the class, ठीक है. I'll share the link on the group, and the class will be on flags that we have in your computer architecture, ठीक है. So try to attend the class, and if you have any doubt apart from this page table entry one, I'll just see to it and then we'll discuss in class tomorrow, ठीक है. Apart from this, if any doubt, you can message me on Telegram. Okay, that's it for today. See you all in the evening. So thank you everyone. Bye bye, take care.